episode of Progress, Potential, and Possibilities, discussions with fascinating people designing a better tomorrow for all of us. I'm your host, Ira Pastor.
Welcome, everybody, again to another episode of our show with another fascinating guest helping to create a better tomorrow on many different fronts. Today, we are going to continue our virtual around the world road trip. We are headed over to Israel today, and we're going to stop and chat with the co-founder of a company called Moonscape, Yoav Landsman. And Moonscape is a really interesting lunar services and payload transportation company that is focused on providing a range of services like communication relay, cutting-edge imaging, ultimately all while delivering payloads to the moon. Moonscape's vision is to support humankind's effort in re-reaching the moon in a sustainable and responsible manner as humanity's first step towards the rest of our solar system and beyond. Yoav graduated from the Technion Institute, Israel Institute of Technology, with a bachelor's in Aerospace Engineering back in 2002. And during his last year of studying, he began working at the Israeli Aerospace Industries as a satellite engineer in the AMOS Communications Satellite Command Center, where he helped modernize operation methods, lead the absorption of new satellites to the fleet, and later he became the head of the satellite engineering team at the Operations Center. In 2011, he became the chief systems engineer of Israeli Aerospace Industries, and then their most advanced satellite, the AMOS 6. At the same time, he was studying for his master's degree in the Department of Geophysics and Planetary Sciences at Tel-Aviv University. Yoav left the industry in 2012 to put his passion and skill into education and public outreach, became a long sought after lecturer and interviewee for science, technology, everything involving space. And in mid-2013, he was recruited by Space IL to the role of senior systems engineer for the Bereshit lunar lander. In 2019, Yoav was the deputy mission director for the first ever privately funded lunar mission. Yoav is an alumnus of the International Space University Space Studies Program, where he studied both in the business and the management department. And in 2019, left Space IL to become a private space entrepreneur. Welcome, Yoav Landsman, to the show.
Thank you. Thank you for the warm welcome.
Absolutely. Absolutely. It's you've had a fascinating past couple decades. I'd love to start things off just by handing the mic over to you for a little bit, just to further talk about yourself a little. If you could take us back a little bit to sort of everything from where you grew up in Israel to when you developed your interest, not just in STEM, but ultimately in looking at the cosmos. And if you could take us a little bit on a little journey up to the Bereshit lunar lander that I didn't touch on, that would be great.
Okay, so where to begin? I think that first of all, I grew up in a place called Kfar Saba in Israel. It's in the middle of the country, not far away from Tel Aviv. And as far as I remember myself, and of course, this is how my parents presented, I was very curious, and I wanted to learn everything about everything. I literally read several encyclopedias in the days where we read physical books. I went to the library a lot, and this was a significant part of my life, being a nerd. But I think that space always fascinated me more than anything else, more than dinosaurs and other things. But it was always combined with science fiction novels and films and TV series, and so it was always something that interests me in the intellectual way of learning about astronomy and facts about space. But with that, it was always something to imagine. How will humanity live in space in the future? and what can be accomplished by that, and what are the technologies that will be evolved in order to achieve that. So it was, as I see it, part of my life from the beginning. And when the time came to choose the course of my career, or at least what to study, I chose aerospace engineering, but that was my second choice, because, you know, at that age, and this is something I try to explain to people at that age a lot, that I thought that what I should do is to pick the course of whatever is the most ambitious and the most and the thing that is harder to get. And at that time it was electrical engineering. So I actually submitted to that, but I wasn't accepted to that. And then I got my second choice, and I can't say that I regret that. So this is some kind of, you know, it's how life chose for me the course of my career, but I'm glad that this is what happened.
Absolutely.
So I went through my studies, and then when I finished, or a bit before I finished, I started thinking about what to do next. Where can I work with aerospace engineering degree? And it seemed to me that there aren't many options, at least in Israel, to work on that, on the interesting part. I mean, there were aircraft industries and other places where they needed people that understand aerodynamics and aeronautics and stuff like that. But this was not the reason why I went to study aerospace engineering. I wanted to start to work in space projects, and it was just the beginning of the Israeli space industry, and it was, people didn't talk about it that much. Part of the reason is probably because originally it came from the defense needs. But at some point I found an ad that calls for aerospace engineers for a space project in the Israeli space industry, specifically for the communication satellite, and that's how I got into that. So it was civilian projects, and there was no actual reason not to publish it and talk about it. But since it was a defense industry, it was under the restrictions that you actually can't talk about it, and it's not something that they're happy to let people know about. Right. I'm very glad that it changed lately. So I worked there for 11 years. During that time, a few years after I started, I had a chance to go study systems engineering for a master's degree, subsidized by the company. But about the last moment, they canceled it because it was a rough year financially, and they decided not to send anyone from the employees to study that year. But I was eager to learn something new. So I thought maybe to do that on my own, but it was one of the one of the academic degrees which are very expensive, so I couldn't afford it. Mm-hmm. So again, I chose something that was my second choice, which is planetary sciences, which is, first of all, not engineering at all. Mm-hmm. But it was super interesting to me. I wanted to learn more. I knew by that time several people that went to that faculty in Tel Aviv, and I heard very encouraging stories about that department. Mm-hmm. So I went to study there, and this is how I did my master's in science, in physics, instead of engineering. But I found out, even though it's not very common for people to have one degree in engineering and the other in sciences, that it helped me quite a lot in my career. The diversity, the different ways of looking at the same problem. Sometimes it was an advantage to look at it not from the point of view of an engineer, but from the point of view of a scientist. So it was very helpful and very enlightening and inspiring. And since originally I was a very multidisciplinary person, I felt that it's quite fit to what I want to learn. Mm-hmm. And in addition to that, it's not just to learn and enrich my knowledge, but I started doing a lot of outreach and education programs on my own, on my free time, like writing a blog, giving lectures. I visited the schools and gave them talks. And I figure out that, first of all, something that I knew from the beginning, that space is something that can be easily be used as a tool to inspire people, to get people think about the future. Yep. I think space is the best representation of the future. And if you look at it in maybe in a marketing thinking, a lot of logos of companies and organizations that deal with something futuristic, their logo or symbol is a rocket ship. Mm-hmm. And it's not just a rocket ship, it's a rocket ship with windows. Yeah. It's a human type rocket ship. So it's not only that space is very inspiring and get you thinking about the future, and it also means optimism. Yeah. But in addition to that, people rarely know about space at all. Sometimes they get some of the stuff that you learn at school, which is mostly basic astronomy or things about the solar system. Yep. But there's so much more than that. There's a lot of achievements that humankind has already achieved in space. There's a lot of, currently, of course, there's a lot of plans to work in space, but there's also a lot of things about the origins of the Earth and of life on Earth and how water came to Earth, and many of the things that influence our lives or influence the humanity or the entire flora and fauna of the Earth. Many factors come from space. Yep. It's like solar activity or comet impacts and other things. so it's something that it's something that I found out that people really like to learn more about that, about space, about what we can do in space, why we do things in space, how our space activities help us, help people here, because it's not trivial. Maybe if you are you are in the community or in the industry of space or satellites or stuff like that, it sounds very, very trivial, but it's not. Many people don't understand why GPS is working. It just does, right? And also the things like Google Maps and a lot of other things. I mean Google Earth, but a lot of things come from space to our benefit, and we can do much more.
I can completely agree with that, and it's funny because I've been just talking about sort of the final frontier, the next frontier concepts. I've been introducing my kids to Star Trek, and even in the 1960s, it was amazing how much we talked about the potential, even through sci-fi, and we need to be doing more of that, in my opinion, as well. But anyway, so you're creating the that science reality from science fiction, which is exciting, and getting this new generation reinvigorated and interested, which is really important. As I was reading through some of your materials on Moonscape, you talk about how obviously the moon and lunar missions have not been a tremendous part of the sort of the budget and the exploration plans the last couple of decades. That's going to change now, not just those agencies, but we have a lot of the commercial companies that are developing stuff for the moon in terms of landers and other types of robots and so forth. And we'll get into Moonscape in a bit, you're designing Moonscape as sort of the service component of all that, getting stuff ready for when all these new devices and so forth get up there and get operational. Talk just a little bit, if you would, about sort of where we are in 2021 with regard to how we're looking at the moon versus Mars and other stuff we're doing, say, in the space station. What are some of the core focuses of the folks that want to get to the moon? What are they thinking about today in terms of A, B, and C?
Yeah, so first of all, I think it starts with the Apollo program. In the past, in the 60s, the United States sent people to the moon and back safely. People worked on the surface of the moon since 69 till 72, and there were several rovers and other spacecraft later.
Yep. Until
76. I think this is the last Soviet mission to the lunar surface. But we didn't do anything like that since. And for people that love discussing the space age, this is a very frustrating status that we're in. Let me try to put it in other words. Going to the moon is going to another world.
Yep.
It's going to a world that is about 400,000 kilometers away. Since December 1972, when Apollo 17 came back from the last Apollo mission, they came back from the moon. Since then until now, no one, not a single person, went higher than about 600 kilometers from the ground. Now it's 600 against 400,000. So we humanity made such an achievement of sending people over there to another world, and we stopped. We didn't do anything like it. This was a event that a lot of people refer to as something that divides history to before and after. This is a very significant moment in human history. And what did we do since then in that type of deeds? And it's understood. The reasons are very clear. It was a political race, and it's a bit like in sports. You achieve something, you try to achieve something, but in sports you don't stop running after an Olympic record is broken. You try to break that again, and this is what we would expect we would do if the political system helped to do that. But there were many reasons why it stopped at that time. So it's clear. But now we're talking about getting back to the moon, or getting to the moon in order to get farther away, because there is a chance to do that. Space flight is much less expensive than it was before. It's not it's not something that only governments can do. And the technology is much better and safer and more reliable. We understand more of the things that we didn't understood then. Some we understood during those missions. So why not continue doing that? And especially if we want to get farther away, like to Mars and to other places, going to the moon, which is closer, and we did that before, so we know a lot of the how-to in this kind of adventure. If we can achieve that in modern tools and methods, and with modern missions, this will help us to get to Mars in a more safer way. Now, some people say that we should go directly to Mars. It's not, space travel is not something safe, and we should just take the risk, and so on. In a way, I agree to that, but I think that if we start doing that in a way that disasters will come with it, and they might happen, it might shut everything off again. And this is something that I really don't want to witness. I want to do that in a gradual way, and to help doing that, to help people do that. So I think there's a lot to learn before we go to Mars. We can send robots there by all means, but human lives are obviously more precious than that. So we need to start exploring the moon with robots, but send human beings over there, because part of doing that is to have the ability to share the experience. And trying to achieve that only with robots sounds to me like instead of traveling the world, the Earth, you can look at pictures or look at Google Maps and read reviews of other people. It's still good, but it's not the same thing. And I think that you can see that there is demand for people that wants to go to space and wants to go to the moon. It's just in most cases currently it's too expensive, too risky, but we can change that. It's not impossible, obviously. People did that a long time ago, so we can do that today with modern technology, which will make it sustainable and much more reliable and safe. So the only question is when, is how fast we can reach that point.
And continue along that. So here, here's your idea for Moonscape. The principle being lunar services, payload transportation, sort of getting that infrastructure in place. Talk a little bit, if you would, about the communications. Obviously nothing confidential, but your thoughts on sort of what you're designing in terms of communications, the imaging, and then you talk about different payload bays that may be in orbit, that take small landers down. So walk us through that.
While I was working on SpaceIL on the Lunar mission, I came across a lot of people from the world that told me directly or indirectly how important is what we do. Not necessarily by the practical thing of going to the moon, of sending a probe to the moon, but by showing the world that it's possible today, it's possible with current technology, and it's possible with private funding. And this is why I immediately after, or actually it was even before we flew to the moon, I started to look for ways to continue the work and to send another craft, or to start building spacecraft commercially in order to make the moon accessible, to help other projects get to the moon. And unfortunately, it didn't work out. We ended the mission in April 2019. Our spacecraft got to the moon, crashed, of course. So it was not exactly as we planned, but we've reached the moon. And the feedback from all around the world was great. People that I've never been in contact with from all around the world, from places I've never been to, contacted me and told me how excited they were to see that this is happening. The optimism was enormous. That we can do that. It's a bit like things I've heard for the Apollo missions, that people said that if we can achieve that, we can achieve anything. But there wasn't any plan to start another mission, and I tried to find ways to do something else by myself, because I understood that I can't be dependent on someone else to start it. And therefore, I went in the same summer to the International Space University, and I met a lot of people from all around the world. And there I understood that I'm going to be an entrepreneur, which I never imagined myself as one before. But that was a turning point. So it was a year and a half ago. And since then, I'm working on Moonscape. At the beginning, I thought I had an idea of how to have a lunar lander which will be much more reliable than anything that is currently in existence. But in time, I figure out that it will be very hard to achieve that financially, and the risk is very high, and many many of our competitors in the Google Lunar X Prize already achieved some milestones, and they're going to the moon, to land on the moon in the coming years. Mm-hmm. So I at some point I understood that this is not the right path for me, for Moonscape, and I understand. And then I understood that I can achieve a lot by just staying in orbit and provide services for the other missions to come. So first of all, the number of lunar missions is quite high. I don't know if our listeners or viewers are aware of that, but currently, just from published sources, there are about 100 missions to the moon in the current decade.
Okay. And
there are almost 100 commercial projects that plan or develop lunar activities. Some on the ground, some, some are landers, but some are ground activities like resource utilization, infrastructure establishment, and a lot of other very interesting things. And the thing is that the traditional way of thinking about space missions, or specifically deep space missions, is that you have to take care of everything by yourself. You need to take the best communication system, or at least the sufficient communication system and propulsion and navigation system, and everything you need to take care. You need to take care of it by yourself, by your mission. You don't have another choice because there aren't any infrastructures over there. But it's going to change because this is not a sustainable way to do things. Yeah. You need to expend so much resources on things that are not your mission. Mm. Right? So if you design a satellite, obviously you need communication systems and processing power and propulsion and navigation and everything else. But mm-hmm. But if you're going to send data from the moon, for example, to the Earth, you need a communication system that is suited for those distances, mm-hmm. right? So the power consumption will be high, and there are other constraints and obstacles to achieve that, and it's something that make your spacecraft quite big. But if there will be a communication system around the moon already, or in Lagrange point between the Earth and the moon, or any other solution, doesn't matter. You can use a smaller transponder and transmit with low power your data to that infrastructure, and that infrastructure will transmit it to Earth in their way of doing that. You don't care, actually. Okay, so or if you need to navigate there, and there will be some kind of a GPS system around the moon, mm-hmm. Then you don't need to worry about navigation. Yeah. Right? So it makes things much simpler, and you can focus on your on the things that you meant to do. Mm-hmm. Whatever you like to do, you can count on others to serve you for payment, of course. But this is easier than designing everything and take everything on top of your spacecraft. So there are plans supported by NASA and ESA and other organizations to support the establishment of infrastructures like navigation, mm-hmm. and communication and transportation, like spacecraft that you are launched on top of them, and they take you directly to your place, wherever it's going to be. And I figured out that there is something missing, which is observation. And this is something I want to focus on. I'll probably find myself doing other stuff as well, but this is the focus at the moment, because it's missing. Landing on the moon is the most riskiest part, the most risky part in surface missions.
Okay.
Up to this point, I can say that from my own experience. But
Sure.
But if you are a commercial mission and you need to do something and gain revenue on the lunar surface, you need to land there softly before you start. And this is something that we can do. We did that before. People did that before. JPL landed on Mars very successfully with Perseverance recently.
Yep.
And we can do that. But it's not 100% reliable, of course. And the question is, how much risk are you willing to take? And if it's a commercial mission and not NASA, you're betting the future of your company on that.
Mm-hmm.
And also relevant for NASA, when they're going to land astronauts on the surface of the moon or Mars, they would like to have the minimum risk they need.
Mm-hmm.
It will never be 100% sure, but it's even for an airliner to land somewhere in the world, it's not 100%
Sure.
Safe. It's very safe. It's very close to 100%, but it's not. And we are not afraid of that. I mean, most of us are not afraid of that, and we are booking tickets and fly around the world, and it looks safe. It looks easy, even, right? And if you ask pilots, they'll tell you if it's easy or not. But for us, it looks easy. And one day, landing on the moon will look easy in the same way. So one of the reasons it's risky is that we can't really see obstacles on the surface. We see the large ones,
Right.
but the maps of the moon are not detailed enough. And the reason is the instruments and the spacecraft that took those images, which are scientific explorers. They were not designed for a better resolution. I suppose for science it's good enough.
Mm.
But if you want to see obstacles the size of your lander, you just can't. So there's huge efforts they make huge efforts to develop image processing tools to see things that are not really in the image by combining data from different tools and different cameras or different methods of measuring the ground. And there are a lot of efforts to develop hazard identification and hazard avoidance tools, which are great. They work very well for Mars, for example. But the question is whether it's enough for human missions or for very, very expensive missions. And I'm not sure that it will be. Actually, I know that there is a case for better images. And it's not just that. I mean, looking at the moon for the missions that are already walking on the moon, it's something that will will be needed. I mean, we can't. We need Earth observation currently in order to do a lot of things, of managing assets, of mapping, planning, and a lot of other things that help us in daily life and help the economy.
Sure.
It will be needed on the moon once there's enough activity on the surface. And my claim is that it will happen sooner than people think. Because if you look at 100 missions, and I bet there are more, but 100 published missions that are going to the moon in this decade, they're not going to stay operational for a few hours or few days, maybe at the beginning, but eventually they're going to stay there for long, because after you expend so many resources to build them and test them and send them there, you need them to survive for longer. And you can see at the Chinese missions that are the only missions that are that have landed on the surface in the last 10 years. Mm-hmm. They're working for years. I'm not sure that they planned for this, but it still works. So it's still operational. But if you calculate that, it means that by the end of the decade, you will have more than 100 operational missions on the surface. And some say that I'm thinking too small. That it would be much more. Okay. And I can see that it's going to rapidly increase, and it means that first of all there will be a lot of need for observation, but for other things as well. Mm-hmm. And the second of all, especially when everybody is concentrating on the South Pole right now, mm-hmm. There is the chance that there will be conflicts over there, because the space treaties are probably not enough to define exactly how to deal with that. It only says that you can't have territories on the surface. Mm. But how do you deal with unintentional damage that someone caused to others? And or if you allow others to get closer to your mining operations, or I don't know what else, and are you responsible for them? And how to deal with that? How to govern something that is that cannot be governed? So it's a problem that many people are discussing these days. Sure. It's quite interesting, and the thing is, what is I find very interesting is that the moon is a place where you need collaboration much more than places on the Earth. Mm-hmm. It's not just that the environment is much more hostile, and you need to depend on others to respond in an emergency or something like that. It's not just that. It's also the fact that you affect others much more easily. Mm. For example, every time you land on the moon, even with small vehicles, you cause something like a sandblast sure. of the regolith, of the dust of the moon. It's spreading to all directions. You don't have atmosphere, so it's not like, it doesn't look like clouds. Every single particle goes into a ballistic trajectory. Yeah. And since the gravity is low, it reaches distances that are hard to imagine. It can sometimes with the larger landers, it literally goes into orbit, or even to escape velocities. So it affects everything on the surface and above the moon. If you and if we neglect that, if we don't find any way to restrict that or to mitigate those effects, then we will cause damage to others every time we land on the moon, lift off from the moon, hop on the surface. Maybe even some mining operations will do the same.
Yeah.
And we need to find ways to do that. And there are a lot of ideas of how to do that, but they need tremendous planning and work in order to achieve. And that will also require collaboration. Otherwise, we can't have everyone taking care of themselves.
Right. Of these 100 or more, if we're being less optimistic or over optimistic, what are some of the, obviously after you get the infrastructure in place and you have great imaging and you got the communications and you're safely, delicately landing vehicles and so forth. What are the hot areas? When you mentioned mining, obviously we hear a lot about sort of the helium-3 stuff and all that. Water, of course, is something everyone's keen about. What are some of the lunar exploration ideas, concepts that you're kind of hot on and excited about seeing what happens?
So first of all, one thing that can be a really interesting activity on the surface will be probably tourism.
Okay.
So people will just go there and do stuff.
Okay.
In pure exploration, we can talk about lava tubes or other types of caves and caverns underneath the surface that are there. We know that it's there in several places where volcanic activity took place. And this is very interesting. First of all, we don't know much about what we can find over there. We can just refer to what we know from Earth, from the same geological phenomena on Earth, but it's different there because the gravity is much lower, so we expect to have much more, much larger tunnels, and maybe and also it can be older because you don't have any effects of wind and water and stuff like that on Earth degrade a lot of geological phenomena. So we will learn a lot about the regions of the moon and the things that happen to it along the ages. So it's also very interesting because we learn a lot about the moon, but also we learn about phenomena that happen here on Earth, but we just can't measure or can't find good evidence for because of the natural wear and tear of the weather and the water and everything else. For example, I hope I'm not mistaken here, that the oldest rock that we ever encountered was something they brought back from the moon. So there's a lot to learn. And this is something that might also contradict the activities for building infrastructures for human activity on the surface of the moon, because every time we do something like that, we affect the environment, right? We know that from Earth, and if we are not doing that wisely, and we're not that good at doing that in a smart way, there's a lot of damages and things like that. So one thing we can do with observation constellation is to map and follow the changes that happens on the lunar surface due to the human presence or the robot presence on the surface. This is something that we never been able to do here on Earth because we started doing that just in the recent decades, and since the beginning of human civilization, or especially since the industrial age, there's been too much changes. So we find indirect evidence for that. But here we have a chance to follow that, to see exactly what our presence is doing to the moon, to the environment of the moon, which up till now was almost static, but it will start to change rapidly as when you have a lot of activity on the surface, and the more lunar missions we'll have, and I believe it will increase rapidly. The more rapidly the changes will be.
You do a lot of outreach. You talk to, as you mentioned, maybe a lot of the sort of the next generation coming along in terms of STEM, in terms of space. For the sort of the next generation, the younger listeners that may be listening, watching this particular show, that want to come work for you one day at Moonscape. Some advice. Should they be following your path in aerospace engineering and geophysics and so on? Are there other skills that maybe not today, but 5-10 years as this infrastructure gets in place that the Moonscape employees should have? Talk a little bit about what you recommend for that next generation that's listening.
So I think that one of the nicest thing in space, in the space industry, or in the space activity, is that we need everyone.
Okay.
Of course, we need engineers and we need scientists. That's easy to see why. And we need programmers and material specialists, but we also need we need policymakers, and we need lawyers, and we need and when we're talking about human presence, physical human presence on the moon and in space, we need psychologists, and we need medical doctors, and we need artists and writers and journalists and storytellers, because this is part of the human experience of that. It's not something, it's not some niche that is very specific in the expertise you need. We literally need, I dare to say, every kind of expertise, and this is one of the things that makes it so interesting to me. And this is something that I really love listening to. I'm thinking about a panel that I watched. That the topic was human presence on Mars. but the panelists were anthropologists, biologists, a medical doctor, a lawyer, and I mean it's not the usual people that you expect to talk about Mars settlement.
Mm-hmm.
But this will be crucial. You need all kinds of different types of thinking and different types of expertise. You need a lot of talented and skilled people for that. So to answer your question, of course, the first people that I will hire, the next people that I will hire will be people that are skilled in engineering and science and business things.
Yep.
Right? We need those too. Accountants and people that understand financing and economics.
Yep.
But eventually, if you look at the entire ecosystem of we call it the cislunar ecosystem,
Okay.
You will need all kinds of skills. So it doesn't matter if you're not a very good engineer, but you are a great reporter or a great physician or something like that.
Mm-hmm.
Let's talk again in a decade or so.
Absolutely. That's good for everyone to hear. As you were saying, you need everybody for missions like this, and it's going to be, you know, whether you're an engineer, whether you're a lunar lawyer, or what you know, ever it may be. It's there's potential for everybody here. So that's an exciting message. You know, one final question, and obviously this is confidential. Don't go there. I mean, maybe we don't know, but love to get your you know, thoughts on the matter. Obviously, you know, you mentioned you got the Bereshit lunar lander there. Little hiccup at the end, but there was some travelers on it, including one of my favorite species on this planet, the tardigrades. Which are pretty damn resilient. Any thoughts? I mean, I don't know. You don't have the optics at this point, but any idea if they're hanging out, colonizing, or any thoughts on the matter?
That was a very interesting case of legal precedent. The thing is that even now we can't be sure that it was really there in the first place. It's just that only after the fact there was an announcement from the people that produced and provided us with something like a time capsule that we took to our voyage. They said that they added a tiny capsule with tardigrade and human DNA and things like that. And they didn't tell us that in the first place. And all of a sudden, after it was published, we were under investigation from the authorities and from the FAA, because it was launched from the United States. So we need to answer to them as well. So the facts are that we didn't know about that. And that guy that published that said, admitted that he never told us about that. But the fact is that we got ourselves into a situation where we maybe have that we maybe have may include a biological addition to our spacecraft. When we reported to the authorities that there is no such thing on the spacecraft. This is something that you need to report if you take. Well, they ask you if you take any biological samples or anything on your spacecraft. So this was a very for me, I was furious when I heard about it. I mean, it was something that shouldn't have been done. You don't want to have some maybe illegal substance on your spacecraft when you reported that you are going by the laws of Israel and the laws of the United States. You don't want to mess with them, and so it got us into that in such a way.
Got it.
So if they got to the moon, I don't know if they could have survived the crash. The company that provide the tardigrades, if they provided it, they said that they calculated that they could have survived, but they are sealed in a capsule. So I'm not sure that they could spread and live and whatever. But if it's there, it will be nice to try to find it some way.
Yeah.
Right.
Yeah.
Even though it's not the most interesting biological sample you can find on the surface of the moon currently, because the Apollo astronauts left their their human waste on the surface, which will be super interesting to find out if something is still living there after all these years.
Yeah. I don't know. It's fun. The indestructible story of the tardigrades kind of interesting, but we'll see. We'll see what happens when some of these missions get back there with Moonscape's assistance. So, it's a it's a fascinating set of initiatives, Yoav, and I'm really wishing you the best with this next part of your journey moving forward. It's going to be a fascinating next couple decades, and wishing you the best with all this. For everybody that's going to be listening to this particular episode on the podcast or watching on the YouTube channel, you've been listening to Yoav Landsman, co-founder of Moonscape, the lunar services and payload transportation company that is supporting humankind's initiatives to get back to the moon responsibly, sustainably, not just for the moon, but for the rest of the solar system. Yoav, it's been a really interesting time talking to you and hearing all about your journey. I just want to thank you for taking the time out of your schedule to talk with us, and thank you for all the work you're doing. And as we say on the show, thank you for helping to create that better tomorrow for all of us via these initiatives. It was a real pleasure.
Thank you for having me.
Absolutely.